Hello Year 11. This is the second lesson in topic CP12 and it's called Energy and Changes of State. Three objectives. What effect does heating a substance have on the particles of the substance? How can we reduce unwanted energy transfers? And what do specific heat capacity and specific latent heat mean? Thermal energy. Energy transferred to a system will be stored and the movement of the particles of the system will increase. And overall, this increases the thermal energy of the system. So the thermal energy is actually the movement of the particles within that system. So if there's more thermal energy in a solid, then I'm sure you're already aware, the vibrations of the particles will increase. And you can see in the little clip there, as it increases, the particles start to move about more quickly. So in liquids and gases, more thermal energy increases the speed of the particles. In solids, it will increase the vibrations. They'll vibrate further and more quickly. So they're moving fast now, and the temperature will come down and they slow right down. So temperature is actually a measure of the movement of particles. Temperature is actually the average kinetic energy of the particles. Temperature is not the same as thermal energy. A kettle full of boiling water contains more thermal energy than a cup of water which is also boiling. So they're the same temperature, but they're different amounts of thermal energy. Why would that be? And what are the units of temperature? What are the units of thermal energy? Well, it's fairly clear the reason why the kettle has more thermal energy is there is a greater mass of water. So although the water is the same temperature, if it has a greater mass, it will have more thermal energy. Units of temperature, we usually use degrees centigrade or Celsius. Units of thermal energy are the same as any unit of energy are joules. So they are not the same thing. You'll already be aware that thermal energy is transferred. A warm body, a warm object, will have energy transferred from it to a cooler one. In other words, hot things cool down. To maintain the store of thermal energy, the warm object must be insulated, usually with something that contains air, because air is a good insulator. So the examples given there are wool or foam or bubble wrap. And you can see in the picture there's somebody installing foam in a loft to insulate the loft, prevent or to reduce thermal energy lost through the roof. You can't actually prevent thermal energy transfer completely, but insulating it can reduce it. Insulation is also used in the reverse situation where you want to keep things cool. So fridges and freezers contain insulation in their doors and walls to reduce thermal energy transfer. So the amount of thermal energy in an object depends on three things. It obviously depends on the temperature. The higher the temperature, the more thermal energy there will be. It also depends on the mass, as we've just seen. The bigger the mass, the more thermal energy for a given temperature. And the third one is it depends on the material it's made from. And that's because it takes different amounts of energy to heat up the same mass of different materials. And that's called the specific heat capacity. It's the amount of energy required to increase the temperature of 1 kilogram of whatever substance it is by 1 degree Celsius. Okay, three questions on thermal energy. Why does 200 grams of water in a saucepan at 50 degrees C contain a greater store of thermal energy than 75 grams of water at 50 degrees C in a cup? Secondly, why does 100 grams of water at 50 contain a smaller store of thermal energy than 100 grams of water at 70 C? And thirdly, why does 100 grams of water at 50 contain a greater store of thermal energy than 100 grams of sand at 50? So in question 1, clearly we have a greater mass of water in the saucepan, therefore as the temperature is the same and the substance is the same, it will contain a greater store of thermal energy. In number 2, we have the same mass of water, the same substance, but a different temperature. So the saucepan, it has 70 degrees centigrade water, so it has a higher temperature. And thirdly, we've got the same mass and the same temperature, but we've got different materials. So water has a higher specific heat capacity than sand. It requires more energy to get it up to 50 degrees C than sand does. Changes of state are obviously from solid to liquid to gas, or the reverse. If we're heating up a solid, when enough energy is transferred, it reaches its melting point. If energy continues to be transferred, the temperature stops rising because the energy that was increasing the temperature is now used to overcome the forces of attraction between the particles in order to turn the solid. So we get what's called a heating curve, which looks like this. So as we start at the bottom, we start at the bottom here and we start to heat it. With time, the solid increases in temperature as thermal energy is added. Once it gets to the melting point, even though we're continuing to heat, the temperature doesn't go up. The thermal energy is now used to break the forces of attraction. When they're all broken, we now have a liquid, and the temperature of the liquid continues to increase until it gets to the boiling point, at which time again the temperature stops rising and the energy is used to break the forces of attraction between the liquid particles and turn it into a gas. When that's all complete, it continues to rise again. The specific latent heat is the amount of energy it takes to make 1 kilogram of a substance change state. So this is the amount of energy that is required at those flat points to actually change the state. But it takes more energy to evaporate 1 kilogram of a substance than it does to melt 1 kilogram of the same substance. So we have two different specific latent heats. We have a specific latent heat of melting and a specific latent heat of evaporation. This heat is given out again when the reverse change of state happens. So when a substance freezes or condenses, the heat is given out. Energy transfers cause quite a lot of effects with weather. So how do the thermal properties of different materials affect our weather? During a warm day on the beach, you may notice that there's a breeze blowing in from the sea. This is called a sea breeze. Sea breezes occur because the land and the sea have different specific heat capacities. This specific heat capacity, just to recap, is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree C. So the water has a specific heat capacity of approximately 4,000 joules per kilogram degree C. So that means it requires 4,000 joules to raise the temperature of a kilogram of water by 1 degree C. The sand, on the other hand, has a lower specific heat capacity of about 830 joules per kilogram degree C. So, which will heat up quicker during the day? The sand will heat up more quickly than the sea because it has a lower specific heat capacity. The same amount of heat input will raise the temperature more. The air is heated by the land or sea below it. As they heat up, they then release infrared radiation, which heats up the air. Where will the air be warmest? And what will happen to this heat? The air above the land is warmed faster because the land warms up faster. The air rises and a convection current forms. So as the air above the sand rises, air is drawn in from the sea to replace it. Warm air in the sea then drops to replace that, and the warm air from the land is taken out to sea, so we get convection current. Energy is radiated by the land and sea all the time. The land and sea cool down at night because there's no energy from the sun warming them up. So they both warm up during the day, but the land warms up more quickly. They cool down during the night, and again the land cools down more quickly because of its lower specific heat capacity. So the reverse situation happens at night. The land cools down faster, the air above the land will also cool down faster, and we get a convection current but going in the opposite direction from the land to the sea. There are also energy transfers when water condenses. The thermal properties of water affect the formation of clouds. Warm air cools as it rises. Water vapor in the cooling air condenses to form tiny drops of water that we see as clouds. So clouds are not water vapor, they are actually tiny droplets of liquid water suspended in air. We've seen that when substances condense or freeze, they release the latent heat that is needed to melt them or evaporate them. So in this picture, there's a very large cloud which will cause a thunderstorm. The cloud has grown very high because of the latent heat released by condensing water. In a cloud, air warmed by the ground rises, and as it rises, it cools down. As it cools, some of the water vapor in the air condenses to tiny droplets of liquid. The condensing water releases latent heat, and the latent heat helps to keep the air warm. The heated air continues to rise, so the cloud grows bigger and taller. Hurricanes cause lots of damage in some areas. A hurricane is a huge storm that's kept going by latent heat released by condensing water. The water that releases this energy originally evaporated from the sea. As the water vapor condenses, the latent heat warms the air, the convection currents get stronger and the wind speeds increase. Once the hurricane starts moving over land, no more water vapor is added. This means no more latent heat is released when the water condenses. The storm weakens and dies out. This is why hurricanes only affect areas near to the sea. Okay, well, that's it for this lesson. So we've looked at the effect that heating a substance has on the substance. It makes the particles vibrate more in the case of a solid, or move more quickly in the case of a liquid or gas. We can reduce unwanted energy transfers by insulating. We can't stop them completely. And specific heat capacity is the energy required to raise the temperature of 1 kilogram of a substance by 1 degree C. And the specific latent heat is the energy required to change the state of a 1 kilogram of a substance. And you will have a different value for specific latent heat of melting and specific latent heat of evaporation. Okay, as always, I'd like you to complete the worksheet and the multiple choice quiz. You've got a choice of worksheets, just do one of them, or you can do both if you really want to. And I've also put the book pages there if you want to refer to those. Okay, I'll speak to you again soon.